Hello everybody, today I'm gonna show you how to determine optimal number of clusters using three methods or three popular methods. The first one is the elbow method, the second one is the silhouette method, and thirdly is the gap statistics method. And to compute the elbow method, let's see first its algorithm. The first algorithm of elbow method. It is computing of clustering algorithm for different values of k. That's based on your preference. If you set 15 clusters, so you will it will compute for 15 clustering. So the second one is for each value of k. That means for each value of number of clusters that you are assigned, it will calculate the total within cluster sum square. And certainly it plot a curve of the total sum square, so total within cluster sum square to the number of clusters that you given. If you given 10, it will calculate for 10. So, and certainly for in the false, it locates, it indicates you the location of bend or the location of knee in the plot, which is generally considered as an indicator of the appropriate number of clusters. So to do that, you have to here seed set function. You have to use seed set function. That means to create a random number of generator, which is help to make reproducible result. So if you do in this way, you will get the same result, or you will obtain exactly the same result in this like this tutorial. So to do that, you have to use this total within a cluster sum square. Then the function is the k, then under that k means, and here is, if you remember in the previous video here is df is our data name, k is the number of clusters, and also here is n start means it is the number of random starting partition when the center is number. So R use 1, but to have a stable result, you have to set 25 or 50, then run here. And in order to set this k value, you have to, it is based on your preference. You have to set 10, you have to set 15, whatever you want, based on your data. So let's assign here 1 up to 15. That means we'll have 15 k values. So run here. In order to extract clusters between 2 up to 15, you have to write here is total within cluster sum square value, then a map dbl, and we have also k value set with here, that means 15, and also this indicate the elbow method. So run here. In order to visualize the values using a plot, so write here plot and give syntax k value and also this total within cluster sum square values. Then the x-axis will be the number of clusters. So we are expecting around 15 number of clusters, and the y value will be total within cluster sum square. So the second algorithm, it will be, as I mentioned before, that it is what for each k value, it calculates the total within cluster sum square. So here is 19. If you want to draw in the form of point and form of star, you can change the number as you wish. So let's run here. And over the right side, as you see here, let me zoom in, and the number of cluster on the basis of total within cluster sum square is 4, because the fourth algorithm tell you that the place that show you, that means the location of a bend in the plot, is generally considered as an indicator of an appropriate number of clusters. So the bend is around here. So on the basis of elbow method, the maximum clustering or the maximum number of clusters is 4. And this plot represents that the variance within the cluster, the variance within cluster, and also it shows you it decreases, it decreases as the number of k increase. as you see here, k from 2 up to 4, 6, 8, 10, 12, 14. But the value of the total sum square is become what? It's become decrease. In the 2 is high, in the 4 is somehow, but coming to 6, 8, 10, and 15 here it's become decrease. Not only that, this bend, as you hear, this bend or almost here indicate you that additional cluster beyond this value of the fourth value of little values. So by this way you can set your maximum or optimal number of clustering. But in case if you want in short and precise way, so write this FVIZ and NBC class and write your name. DF is our data name. So and here also K means the method is WS, that means total within cluster sum of squares, or elbow method. And if you want to draw some geometry line, especially the vertical line, so write this syntax: geometry vertical line, existence set is 4 and the line type is 2. If you want a broken type, you have to use 1. If you want to bold type, you have to change it to 3, whatever you want. So run it here. So as you see in the right side, it gives you the vertical line, so the optimal number of clusters using the elbow method is 4. Coming to the second one, that means the average seal-out method. So average seal-out method is one of the techniques that help you to determine the optimal number of clustering. In short, the average seal-out approach measures the quality of clustering. That means it determines how well each object lies within the cluster. So if you get high average seal-out width, that is indicate you it's the maximum or the optimal number of clustering, and indicates you have a good clustering. So to do that, you have to use average seal-out or AVG seal. The function is k. Then here also you have k-mean result, and your function is k-means. Our data name center is k. That means if you have 10, 15 on based on your preference, so it will be k, and the n start is 25. The method is seal-out method. Then and run over here. And also you have to set here your k values. Sorry, there is unexpected, so it's better to select this one and run together. So by this way you can correct your error. The k values, here the k, so you have to set up to 15, so right here, and also extract your result. To extract your result, write average seal-out values, then the map DBL, then the k values. Here you set 15, you expect 15, and the method is what? Average seal-out method. So run here. So in order to visualize in terms of plot, right here, and your x-axis should be number of cluster, while your y-axis should be average seal-out method. So you prefer the maximum width. Yeah. So let me zoom in and determine the optimal number of clustering. Based on the average seal-out method, as you see, the maximum width obtained here is from 2, and the second one is obtaining is from where? From 4. So the average seal-out method tells you that to cluster your dataset into 2 groups. And if you want to draw in a very short and precise way, you have to use this syntax. That means you have a function from the factor extra, FVIZ, and class, and your data name, right here k-means, and the method is seal-out method. So it will show you in a graph. Yeah, so by this way, you can determine your optimal number of cluster using average sellout width, which means, which means if you have large value of width, so that point will be your optimal number of cluster. For example, if it is 3 here and if the point is around here, it's greater than 2, so it will be 3. So based on this one, you have to cluster, you have to group your data into two clusters because it's at the maximum average sellout width. So by this way you can determine your optimal number of cluster using the average sellout width or methods. And lastly, the gap statistics method. The gap statistics method is somehow have different techniques, but it is one of the methods that to determine your optimal number of cluster. And this approach can be applied to any clustering method. That means k-means clustering or hierarchical clustering. And the gap static method compares the total intra-cluster variation for different value of k that you are going to set with your, and not only that, it also calculates their expected values under null reference distribution of the data. That means a distribution with no obvious clustering. So the reference dataset is generated using the Monte Carlo simulation of the sampling process that are used to estimate each variables in the data that we are going to compute the range, and also it generates values for the endpoints uniformly from the interval of minimum to the maximum. So let me see it. And as usual, you have to set, or you have to create a random number of generator or generation here. So you have to set 400, 200, 300, 120, whatever you want. So run here. And here the method is a gapstat method. So gapstat, and right here this text, and this is our data, and the maximum will be 10, and here is the reference. That means the null reference distribution is 50, and then start is 25. So right here, and you'll get some result on this on the console part. And also you have to print the gapstat method that contain the first max. So right here, print the gapstat, the method is first max, then right here. So based on this result, you can select your optimal number of cluster. For example, here is the gap, and there is 10 clusters that we set on the our script. So on this base, you have to compare. If you compare from 1 to 10, the maximum value here is 0.29. If you compare with the rest, they are less. So this is 4 is the number, or the maximum, or it's optimal number of cluster. So 4 will be the optimal cluster based on the gap statistics method. You can use this number. Either you'll have a chance to draw by this way. So use this function in order to visualize the gap static method visual effects. So write this script or this syntax and run here. So you will see some plots on the right side, and zoom in. Then here is the optimal number of cluster is 4. Yeah, optimal number of cluster is 4. So if you want to extract the result, you can extract the result by this way. So finally, our data set df will cluster the elbow method as well as the gap statics methods, telling us that to cluster our data into 4, while the average silhouette method shows its optimal number of clusters is 2. So based on the two method that means the gap static as well as the elbow method, we will divide, or we will categorize our data set into 4 clusters. To do that, gives us random assignment tasks. Then the final, that means the k-means, our data should be divided into 4, and the first n start is 25. Then run here, and again also let's print the final one. So these are the details. If you need the details, you can get so many things from here, from the result. Yeah, for example, Alabama is categorized under cluster 3, and here the Kansas in 1, Georgia in 3, Colorado in 2, Mississippi in 3. So if you want to visualize in graph form or in good visual effect, so write here FVIZ cluster. So the package cluster used here to classify or to categorize our data into their similarity. So our name that give here is the final, then the data name is df. So yes, we get this result. So the murder, the rape, the assault, and the urban population is finally categorized or fail under 4 clusters based on elbow method as well as gap static method. But the average silhouette method indicate us to use 2, so we use the 2 methods in order to have this 4 cluster. So by this way we are finished. By this way we are determining optimal number of clusters using elbow gap statics method, and to some extent we try to see the average silhouette method. And if you have any question regarding to my tutorial, you can address me through my email and also through YouTube channel comment box. So thank you for watching.